Hello and welcome. These are the solutions to quiz number 6. So how many sig figs should be given with the result of the following calculation? We have 3 times 4 sig figs, so this result here should have a total of just 3 sig figs. But then we need to note what particular placeholder that digit falls in because our next step is adding. So it's really important for us to actually go ahead and carry out the arithmetic here. 5.275 times 9.40, that's 49.5. I'm going to write out the whole thing I see in the calculator because this is good to the tens placeholder. That's the third significant digit. We add 63.5 to that. Tens place plus tens place is good to the tens place. So this should be 113.1 after we round. And then we end up noting that this value has 4 sig figs. So the result should have 4 significant figures. An object has a mass of 6.25 pounds and a volume of 75.0 cubic inch. What's the density, but in units of grams per milliliter? There's the handout that has some information, of useful information you can use. I would clue yourself into the yellow highlighted information. You might see some conversions that are not in yellow that might make this problem a little bit easier, but you may not necessarily have that information available to you on exams. The key conversions I'm going to use here is that 1 inch is 2.54 centimeters, and then 6.25, 1 kilogram is equal to 2.2046 pounds. There's some extra digits given. I think 5 is plenty. So you can round some of the conversion factors to the, looking at the sig figs in the problem to whatever's appropriate. Okay, so our number of grams per ml, what we're looking for. We'll start with our mass in pounds at 6.25 pounds. Go to kilograms, 2.2046 pounds per kilogram. Obviously a kilogram is 1,000 grams. We're going to divide that by the volume, 75.0 cubic inches. And then we need to use that conversion factor that 1 inch is 2.54 centimeters. Then we need to cube that whole factor. I'm going to zoom in a little bit here. Let me erase this part here and rewrite it. So 1 inch is 2.54 centimeters, and we need to cube the whole factor. Because a 1 inch by 1 inch cube, if you picture a cube that's 1 inch on every side, that's 2.54 centimeters. So 1 inch cubed would be equal to 2.54 centimeters cubed. Okay, so we got to cube the whole factor, and then obviously a cubic centimeter is a milliliter. So our cubic inches are canceling, our cubic centimeters are canceling, and we end up with milliliters. So we work this out. So we go 6.25 divided by 2.2046, and then times 1,000. So 6.25 pounds is 2834 kilograms. Divide that by 75, maybe do parentheses around 75, and then times 2.54 cubed. Okay, so I get 2.31 grams per milliliter. Around once at the very end, 3 sig figs. It's not really part of the problem, but if you're tracking sig figs, 3 in both values, our conversion factors were all perfect, or at least contain some extra digits, so they're not leading us to rounding our values. Okay, moving on to number 3. Battery acid is a solution containing water and sulfuric acid. Calculate the mass of sulfuric acid in grams present in 1.75 liters of battery acid if the solution has a density of 1.39 grams per milliliter and the solution is 29.5% sulfuric acid by mass. Okay, so this is a problem-solving problem. You may look at this and say, okay, I've never seen anything like this before. This is really just one way of looking at density, is the ratio of mass to volume. So we're given the density of the solution and then we're given the volume of the battery acid. So we can calculate the mass of our acid solution by just taking the density. In fact, let's just do it this way. Let's take the number of grams of the acid solution to be equal to the 1.75 liters. Let's go over to milliliters, and then multiply by the density. So write out 1.39 grams per milliliter. And a little tip here, a lot of people like to skip writing in the units. Write in the units, and dimensional analysis works itself out really easily so that you're not multiplying or dividing in the wrong order. So we go 1.75 times 1,000, so 1750 milliliters. 1.39 grams per milliliter means the entire solution has a mass of 2432.5, for tracking sig figs, would be right there, grams. So the mass, 29.5% of the mass is sulfuric acid. Okay, so the mass of just the sulfuric acid, which is H2SO4, don't worry about the name, you don't really need to know that, but its formula is H2SO4. The mass of sulfuric acid would be the percent that's sulfuric acid times the mass, right? I mean, so that's just the basic use of what a percent by mass would be related to. So you may get stuck on a problem like this because you've never seen something like this before, but you can walk through it with the information provided and work your way towards solving the problem. We will work a little bit with the percent by mass, as a problem in chapter 3. So maybe looking back on this problem after a couple of chapters will reinforce this type of topic. But this is really just a problem-solving question relating to some of the topics out of chapter 1. So moving on to a few more questions. So let's express 100 degrees C in Kelvin. So temperature in Kelvin. This is an equation that's provided, but it's the degree C temperature plus 273.15. So we would take the 100.00 degrees C and add 273.15. So temperature in Kelvin would be 373.15. Which type of matter below is a pure compound? Oil and vinegar, well, that's a mixture. Seawater, well, that's sodium chloride, other salts in water. Air, that's O2 and N2. Purified water, H2O, and coffee, obviously water, whatever makes coffee. So this is obviously a mixture. Okay, so the one that's a pure compound is obviously the purified water. It's a pretty easy question, I think. Number 6, the conclusion of which experiment supported the hypothesis for the nuclear model of the atom over the plum pudding model. This is getting into chapter 2. You may be doing some reviewing by the time that you're looking at this quiz over the next chapter, chapter 2. So we have a couple key experiments. We have J.J. Thomson's cathode ray tube experiment that sort of discovered the electron. We have the oil drop experiment by Robert Millikan that sort of determined the mass and the charge of the electron. Rutherford's gold foil experiment is the one that actually supported the hypothesis for the nuclear model. And this found this out by shooting alpha particles or helium nuclei at a strip of gold and finding many of the particles are deflected. They're only deflected by having a relatively massive nuclei that can deflect a particle within that gold foil. So it sort of supported the idea that you have small, tiny electrons outside the nucleus, a big positively charged nucleus that then was scattering those alpha particles. And then the oil drop experiment, so mass to charge ratio, or excuse me, the Millikan oil drop experiment found the mass and charge of the electron. The radioactivity experiments just discovered the different radioactive materials are giving off alpha, beta, and gamma rays, where alpha rays are helium nuclei, beta rays are basically electrons, and gamma rays are high energy packets of energy, and then the ray tube experiment discovered the electron. Okay, so number 7, how many neutrons are present in potassium-41? So this is relating to the mass number, so that's the mass number, which of course is the number of protons plus the number of neutrons in the nucleus of an atom. Now, it's of course these two because these are the more massive particles. When you look at the mass of a proton, it's about 1 AMU. Mass of a neutron is also about 1 AMU. And the mass of an electron is about 1/1000th of an AMU. It's something on the order of about 5 times 10 to the minus 4 AMU. So the electron is really, really light. So that's why the mass number is really the particles that carry a majority of the mass in the atom. Now, the sum of the protons and the neutrons is equal to 41, so 41 would not be the number of neutrons present. We have to use a periodic table, look up potassium. Potassium is element number 19, so that's the atomic number. We get that from the periodic table. It's the like the number you see listed for potassium. So the 19th element of the periodic table means it has 19 protons in its nucleus, and so the neutron count would be 41. 41 minus 19 would be the number of neutrons. So that would be 22. So how many electrons does a fluoride ion contain? So an F minus ion, you pick up this minus charge, protons and neutrons have the same magnitude of charge, just opposite in sign. So when you look at fluorine at the periodic table, atomic number is 9, so it has 9 protons. If we had fluorine with a 0 charge, that would have 9 protons, 9 electrons. So you have 9 positive particles, 9 negative particles for an overall neutral charge. If you have a net negative charge, we're exchanging the electrons. They're the small particles on the outside of the atom. Really easy to exchange the electron count, not really easy to change that proton count. That's more or less a constant for all of our elements, at least in a chemical sense. So if we pick up one more electron, then we pick up a net negative charge of minus. So this would have 10 electrons. So 10 electrons for F minus. Okay, that's the solutions for this quiz. Thanks for the attention.